Hello everyone and welcome to this video on modelling components in Fusion 360. In this particular video we are going to be modelling the stepped shaft component that you can see on screen now. If you would like to follow along with this exercise you can find an engineering drawing for the component in the video description below. Okay, so let's get started. Just before we create our first feature, let's have a bit of a think about how we're going to create this particular component. This is a relatively simple component. Here we see a stepped shaft with a number of tiers. Each of the edges has got a chamfer feature on it, and we have a hole in the bottom of the component. Now, I could create this component as a series of extrude features with an extrude feature for each of the tiers of the component, but actually a simpler way to do this is to use a single revolve feature. So that's what we're going to do here. So I create a new design by going to the New Design tab at the top of the window. And then the first thing that I'm going to do is create a sketch. So I go to the Create Sketch button at the top, and in this particular case I'm going to sketch on the XY plane. So I pick the orange square for the XY plane. Now what I need to do here is I need to sketch a profile which represents half of the cross section of the stepped shaft. So I'm going to get my line tool. I'm going to start from the origin of my component, and I'm going to sketch a line which will represent the center line. And then I'm just going to get something which looks approximately the right shape and has the correct number of tiers for this component. To get this final line, to get this to line up and be a 90-degree angle with this particular line at the bottom, if I hover over it and then move away, I will then get a snapping reference to ensure that I can close that profile and ensure all my angles are at 90 degrees. Okay. So now I have the correct shape, but nothing is the correct size. So what I'm going to do is I'm going to go to my sketch dimension tool, and I'm going to start dimensioning this particular sketch. So I'm going to start with the diameter at the top here. If I click on what will be the center line, and then I click on the outside of the diameter, and then just before I place the dimension, if I right click and hold, I have an option for diameter dimension. Now what this option does is it allows me to dimension the feature as though it's a fully revolved diameter, and it means that I don't have to divide all of my dimensions in half, because if I was dimensioning between the center line and the edge, I would effectively be dimensioning the radius. So if I place that dimension there, I can tell from my engineering drawing that this should be a 16mm diameter. I'm happy with that, so I can continue to dimension the rest of the diameters in the same way, with this being 30, this being 40, and the final diameter being 60. Now my diameters are correct, I need to set my heights, so I can tell from my engineering drawing that this is a 40mm distance. I can tell that the next step is a 60mm distance. Then we have 80mm, and finally 120mm. I can tell that my sketch is fully constrained because all my sketch lines have gone black, and I'm now happy with that sketch, so I can click Finish Sketch. Okay, so the next thing that I need to do is I need to revolve this sketch to create the main geometry of my component. So I go to Create and I go to Revolve. The two bits of information I need to give this particular feature are the sketch profile and the axis of revolution. Now Fusion has already automatically selected my sketch profile. If it had not done that, I would see a window like this, and I would have to pick the profile, and then separately I would have to pick the arrow next to axis, and then pick the particular axis. And in this case I know that this is the center line that I'm hovering over now, as that's the way I've sketched this particular 2D sketch. So I can pick that axis and it will immediately revolve that sketch for me. Typically this will default to a revolve of 360 degrees, but much like an extrude feature, you can change the angle through which the feature is revolved, but we're going to leave it at 360 degrees in this particular case. I'm happy with that feature, so I can hit OK. And the next thing I'm going to do is I'm going to create the chamfer features as required in my drawing. So I go to Modify and I go to Chamfer. I'm going to pick one of the edges, and then I'm going to hold Control and pick the additional edges which also have chamfer features on them. And I know that these are 2mm chamfers by 45 degrees, so I can leave this chamfer type as equal distance, and I can set the distance to 2mm. Again, happy with that feature, so I can press OK. Now the final thing that we have to do is we have to create the hole feature in the bottom of the component. In order to do this, I'm going to use the hole feature itself. So I go to create and I go to hole, and I need to give this particular feature some information so that it can accurately place and size the hole. So I know that the hole needs to be on the bottom face of my component. So the first thing I do is I select that, and that sort of roughly places the hole in a location on that face. It's not the correct location yet. I can tell from my engineering drawing that that hole wants to be concentric with the bottom face of my component. So an easy thing that I can do here is, once I've clicked on the face, I can just click on the edge of that particular cylinder, and it will place the hole in the center of that face. If it doesn't do that the first time, you can of course just select the origin point and it will snap the hole to that particular reference. Now I can tell from my engineering drawing that this is a threaded hole, not just a plain hole. So again, I need to give it some additional information here. So I want to change my hole tap type from simple to tapped, and I want to change the depth of my hole from 28mm to 30mm as indicated on the drawing. And then I need to set the diameter or the size of my hole to be correct to the engineering drawing. Now on the drawing it says this is an M18 hole. This means that the size needs to be 18mm. And the designation is M18 by 2.5, meaning a pitch of 2.5mm on the thread. So this is correct, and I can leave this as is. Now we have one other option that we might potentially want to set for threads, and that's this little checkbox here called modeled. Now it might not look like it to us, but to CAD software, thread features can actually be quite complex. They are a large number of edges in a short volume of space, and this can be difficult for the software to process. So typically what happens is that the CAD software does not create the actual thread itself. So if I press OK here, I can see I've got something that looks like a thread, but what the software has actually done is it's just created a plain hole, and then it's put like a JPEG image on the inside of that hole to make it look like a thread. And for most cases this is perfectly acceptable. When we go through to engineering drawings, it will detect that this is a thread and it will display it correctly on the drawing. So most of the time there's really no need to do anything other than this. If you're doing something such as 3D printing or direct manufacture, for example, you will need to model the thread itself. So if we go back into the hole feature by right clicking it and clicking edit feature, we can actually check this text box at the bottom which says modeled, and we can press OK, and we can see now that actually all of the geometry for that thread has been created for us, and if we were to go and 3D print that, all of the information for that thread will be sent to the printer. Okay, that component is now complete and I'm happy with it. Thank you very much for your attention, and I will see you in the next video.